الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
السلام عليكم ورحمة الله تعالى وبركاته. أهلا بكم في عدد جديد من أعداد MENA ديجيتال دايز. معكم عليان عبد النور جي تيزي وزو الجزائر. سأكون بإذن الله معكم خلال الساعة هذه، أين سنتعلم أشياء جديدة عن جوجل كلاود. السيشن ستكون بإذن الله بالإنجليزي، لكن إذا كانت لديكم أي أسئلة يمكنكم طرحها وسنجيب عليها بإذن الله. Hello everyone, الزلف الأون. Aliane Abdenour with you, GDG Tizi Algeria. I will be with you in this hour. We will discover together new stuff about Google Cloud and new concepts. If you have any questions, of course, you can ask them. We will answer them, inshallah. So today's session, it will be like what we did within in this year, in 2021. I hope that you learned something from what we did. So today I tried to make something that I will enumerate the tools one by one. So today you will discover how you can host your application in different ways, and we will discover this how things evolved since the first release of Google App Engine until now, so we can understand the needs of the markets, the needs of because there is always this synchronization between what people need and what do we have as technology. So that's why the products evolved with time. So before we start, I will show you something. You need to understand that the technology that we are using in Google Cloud platform, this is the same technology that Google use, let's say, in-house. What does it mean? That means that Gmail, that means that Google itself, they use those technologies and then Google release them for Google Cloud. So as you can see in this document, let me show you, it's from 2014. And as you can see, Google runs everything in containers. I will explain, of course, a container in a few minutes, even if you didn't attend the session where we talked about containers a lot. So as you can see, even in the past, Google were using containers. We start over 2 billion containers per week. Can you imagine? 2 billions by a week. So we are going to understand how things work at Google. So this is Google Cloud platform. This is what we call the console, as you can see. And in the console, let me open this and let me come back here. So here is what happened with time. So Google, when they started Google Cloud, they started with App Engine. This is what they released first. We are going to check about the dates. And then they released Compute Engine, and then Kubernetes Engine, and then Cloud Function, and then Cloud Run. And the App Engine, there is two version, and then there is a major version. So there is the standard. We are going to check all this. And then there is the flex, the flexible. So we are going to understand how they evolved from this until this. And then you can understand why do you need, because they are still here. So why do we need to use App Engine why we don't use Cloud Run. So in this session, I hope you will understand now how things will work at the end of this session. So let me start now. Let me remove this pen, okay? And let me start. So let's go back in time. So here is it. The first thing Google did, they released App Engine in April 7, 2008. As you can see, we are 2021, we are nearly in 2022. That means that when Google decided to release App Engine, that was for the technology that people needed in 2008. But since we are in 2022, that means that the tool changed because the technology changed. We gained a lot of power. That means that instead of keeping updating the same tool, we need new tools. So then they released Google Compute Engine in 2012 and then Kubernetes in 2014. So when we say Kubernetes, that means Google Kubernetes Engine. We're going to see all of this. So before that, let me show you something. I will explain you all those concepts. So in cloud, we have layers. So we have the IaaS, and we have the PaaS, and then we have the SaaS. So that means those three letters, they don't change. This is as a service, always. We keep seeing that. So the I, that means infrastructure. Infrastructure. And then structure. And the P, that means a platform. And then the S, that means software. But we are not limited on those three layers. There are many layers. Every time there is a new layer. There are game as service, movie as service, for example, Netflix, gaming as service, for example, Stadia. And the software as a service, this is what we are using, for example, in Google Docs. In Google Docs, we are using a software, which is something that we can use in our workspace. This is like Office, but we don't need to understand, is it working on Linux? Is it working on Windows? How much RAM am I using? So that means that I don't care about programming stuff. I just want to use it and use it in the cloud. Use it in the cloud, that means that I can use it on a phone, I can use it on a laptop, I can use it on a television, I can even use it on a fridge. If my fridge has a screen and can run Google Chrome, then that's fine. I can run my Google Docs, Google Sheets, and Google Slides. All those are software as a service. As long as it runs in, as long as it understands what is HTTP, then we can make a software as a service. And then we have the platform as a service. But before I leave this, let me come back to, I talked with the top. Now let me talk about the bottom. Why we talk about the infrastructure as a service, this is something like, hey, give me a machine and let me do everything on it. Because I know what is a network. I know what is, for example, I know how to use Linux, for example, Ubuntu. Or I know how to use Windows Server. So just give me the box and let me do whatever I want. So this is the infrastructure as a service. If your team is good, then bring an infrastructure. You can build everything on top of this. This is like, I am just taking a machine on the cloud. This, instead of buying it, I'm taking a machine somewhere. And then sometimes some people don't want to bother themselves about network and about the Linux or for example, about Windows Server. They just want to program. They know how to use PHP. They know how to use Python. They know how to use Node.js. They don't care about those bottom layers. So what we offer for them, we offer for them a platform as a service. We don't bother them about Linux commands or Windows Server configuration. We just tell them, you know how to use Python, you know how to use Git, then that's fine. I will give you a platform as a service. So this is the first step. Now we have the infrastructure. I take the machine, the platform. I am a programmer, the software. I don't care about those two layers. I just want to invest on my software. So as an investor, you need those two layers, infrastructure or a platform. Then you can realize a software that you can sustain and give people the access. So what Google did, they started with a platform as a service because at that time, people needed a new way to host their application. We need to aim the developers. So Google App Engine, this is a platform as a service. And then sometimes, so let me delete this. So sometimes you hear the word platform as a service. So let me write App Engine. But sometimes you hear about serverless. The serverless, that doesn't mean that there is no server. That means that there is a server, but you don't need to bother yourself. So if we take the infrastructure as a service, you take the server, you do whatever you want. But what if I give you the same power as an infrastructure as a service, but like you are using a software as a service? Then you are in serverless. You use the tool like you are in software as a service, but I give you the power about infrastructure as a service. That's why we call App Engine serverless too, even if it's a platform as a service. But since it scales without asking the machine, without configuring anything, we just try and write one single file, and then that's fine. Everything gets scaled as we need. Why? Because we are in the cloud. So the cloud, to remind you, I have this problem. I want to invest somewhere. So I went to the store, to a professional store. I bought a machine with 128 giga RAM. But at a certain time, I need to invest more money about it. Why? Because my RAM, I need to change it. I need to change it sometimes. I need to change the disk because the disk can go down. I need to verify electricity. I must have 24-hour, 7-day electricity. I must hire an engineer that can a sysadmin or a sysops. Let's call it a sysops, a system administrator, so he can manage this. I need to understand. I need to buy a Cisco, for example, switches and routers. All that costs me more money. And the whole problem about this is the problem. 24-hour, 7 days. My question, do I really need this system to run 24 hours? Do I really need to run it 7 days, 365 days in a year? Imagine that you are having a website about, for example, the end of the year. At the end of the year, a lot of people come to your server because you are selling stuff. For example, like you have a shop, an online shopping. At the end of the year, for example, in December, your website is always online. People keep coming to your website. But in March, no one comes. How are we going to do with this machine? Are we going to shut it down? And imagine that people, when they come to the server, 128 giga RAM was not enough. We need the double. How are we going to do? Are we going to throw this machine and replace it? And when we do this, how we are going to assure that the service stay online while migrating to the new infrastructure? All those questions, we cannot really do them on what we call on-premise. And on-premise, this is when we host everything at our end. That's why the model in the cloud, how it works, I pay for a machine. In reality, I am renting it. I'm not buying it. How much time do I need? The time I need my service. I need it 1 hour. That's fine. I rent my machine 1 hour. and then I only pay for what I use. So this is the concept of the cloud. So the App Engine did that in the beginning and still do that. So people came, they paid for the App Engine, and then I have one machine, let's call it one instance. It was running. A lot of people come to this machine. What I do, I scale. So I just call another instance. And since I'm in the cloud, I can scale to the infinity. That means that the more people come to my service, the more I scale. I don't have a lot of people, that's fine. I shut down my resources and I only pay for what's running. So this is what App Engine does. So what do we have? We have the App Engine. And then in the App Engine, when it was first released, it was released under the name the standard. And in the standard, we have the first generation and the second generation. So the first generation, we had a problem. The problem, here is the problem with it. So if I come back here, and let me show you here, this one. The App Engine, at the end, it uses containers. What does it mean? It means that instead of using virtual machine, I'm using containers. But the problem about containers is that I'm sharing the same kernel here. So since I am sharing the same kernel, that part of the operating system that decides how much RAM and all that stuff, the problem is that if I host it publicly, someone can inject some bad code, and then from that code, he can go to the other containers and poison them. And that was the issue. So this technology, it was limited for public. This is like, okay, you come, you upload your code, and then you maintain it. But don't try to understand something else, because there is a problem about security. So this is the App Engine. So this is the App Engine, the first generation. So in the first generation, it was running only some limited runtimes. That means that if we wanted to run it on Python, that Python, it was specially designed for the App Engine. That means that if some hacker tried to take control about Python, he cannot do a lot. So it was limited. Then what happened? There was the first generation, and just after the first generation, Google released App Engine Flexible. What does it mean? It means that, as you can see, I didn't talk yet about second generation. There was the first generation and then the flexible environment. The first generation, it was limited. Then the flexible environment, you take your own container and you host it. That means that we can create our own Docker, our own container, and host it in the App Engine. That gave the developer more control. And because we are using container, as you can see, custom runtimes, that means host anything you want. You are not limited on language. You can bring to Python 2, Python 3, as long as it's a container. We don't care about what's inside, because it works, then that's fine. Google will take the container. It doesn't bother itself if it's a Python 2 or Java 8 or PHP 5.5. So first generation, then Google released the App Engine Flexible Environment, and then people said, I don't want to use the container. Let me give me like the first generation runtimes, but with more power. So Google released the App Engine, the second generation runtime. And as you can see, the second generation has Python 3, Java 11, Node.js, PHP 7, Ruby, and Go. But if you want something else than this, then you need to go back to the flexible. Now, someone says, hey, what if I want to run Python? What is the difference here? In first generation, I see Java 8. And if I come to this, I don't care about the version. It's not about the version itself. It's about the libraries. Sometimes you need Python 2 and this code. Let me come back here, sorry. You have a code that can run on Python 2, but you can easily convert it to Python 3. This is not the real problem. The real problem comes when you want to use some libraries that are not compatible with Python 3. In this case, the problem is even more bigger, is that you cannot use some libraries at all because it's a sandboxed environment. That's what we call a sandbox. A sandbox, this is like, let's call it something like this. Let me show you something. A sandbox, that's a glass case where you cannot get inside and you cannot go outside. So we sandbox things. So this technology didn't allow to bring your stuff, your own stuff, our own stuff. So what we did, either we use a flexible environment, since it's just a container, or we came back to those practice, but with much more liberty. Who created now the ability to use the first generation practices? That means that we don't deploy a container. In reality, it's a container at the end, but we use the same practice. I upload the code and it works. Who did this? This is what we call the Gvisor technology. So the Gvisor, if I explain you the problem, let me come back here. Here is a small explanation. So the explanation is that we have that space that's called a kernel space. That's forbidden for the user, but the user can still use the user space. So the message that is exchanged between the user space and the kernel space, we call it the syscall. So the problem is that if we give this access to a hacker, he can hack the kernel space. So what did Google in the beginning? It was sandboxed, and then they released the flexible environments since it's a container. Then they go back and then they release it like the first generation. They called it the second generation, but they reprogrammed the syscalls. And reprogramming the syscall, that means that they realized their own technology. It's called the Gvisor. So Gvisor, its job is running containers in more secure way. Why? Because the syscalls has been rewritten. Now, why we are talking about Gvisor? Google, in reality, even before inventing Gvisor, they invented this. And this is what revolutionized the containers. So as you can see, this is like 7 years, 8 years old ago. They realized, let me contain this for you. Google contributed because in the past, we were using what is called LXC. LXC for Linux container. So LXC, it has its own bugs, which means that they are not really sandboxed, which means that if someone goes to this container, he can still hack the other container. So what did Google? They patched this LXC and they invented their own technology. It's called LMCTFY. And if we have Docker now, thanks to this library. And as you can see, if I come here, it says that Google contributes 10 times more code than any other public cloud. Google keeps updating the open source word so everyone can enjoy those contributions. So let me come back to this, to the original thread. Let's go back to the history. So what did Google? They released the first generation, and then they released the flexible environment to let people upload their own container, let's say Docker, and then they released the second generation runtime, where we can still use our old practice, but still enjoy the new Gvisor sandboxed environment. But this is only the platform as a service. But we have something else. If I come back here, I told you that people, they need either to use a platform as a service, but sometimes they need something deeper, infrastructure as a service. So platform as a service, this is App Engine. But if you want something deeper, then you have Compute Engine. Now, Compute Engine, the difference is that you are going to create your own virtual machine. So if I come to here, and then I come to Compute Engine, I go to Virtual Machine Instance. Let me show you something. It's really amazing what we can do with Compute Engine. If I create an instance, there is theoretically an infinite way, an infinite power of machines. So if I come here, let me choose, for example, N2D, which is AMD. You can choose to use Intel machines or AMD. If you like AMD, that's fine. So if I come here, as you can see, check this machine. This machine has more than 224 vCPU and almost 1 tera of memory, 1 terabyte of memory. And the good news, as you can see, you will pay for it $7 the hour. Imagine that if you wanted to buy this machine at your in your own on-premise, that will cost you a lot because you need a lot of electricity, you need to update them and all of that. But since we are in the cloud, I will only pay for what I need. Don't check about the month. Maybe I just need it one day. So why do I buy and invest on something that I will not use the other days? So I will only pay for it. And in Google Compute Engine, I will leave the machine as it is. And if I come here, so let me come to the here, where is it? And preemptible, let me make it on. Check this out, check this price. If I make it on, a preemptible machine, this is a machine that is not meant to run more than 24 hours. So in case I need a machine that has almost 1 tera of RAM, 1 terabyte of RAM, but I don't need it really to run for one day, I will choose a preemptible machine, the same configuration, but I just need to choose it as a preemptible. And as you can see, it will cost me less than $1 the hour. So can you imagine that? And once I finish this, so let me show you something. So once I choose this, I can go to networking. And in networking, I am here reserving an IP address. So I am now hosting my application in the old way, where I need an explicit IP address, and then I get access to this IP address using SSH. So if you want to use this old way, use Compute Engine. So if I come here and let me choose create an IP address, I will name it my website. And then this is my website, www.something.com IP. And I will do reserve. Now it will start counting how much money I'm going to spend on this IP address. Once I do this, as you can see, now I have a virtual machine with an IP address. And as you can see here, the premium service tier, this is a network that belongs to Google. I will use Google's network, which is fast, and I don't need a lot of hops because when I do this command, traceroute -e 888, the DNS server, the Google DNS server. As you can see, the traceroute is showing me because internet is built like this. Let me clean this and then show you something. I am here. So this is, for example, USA, this is Europe, this is Africa, and this is Asia and Middle East, and this is Australia. So I'm here, I'm in Algeria. So if I want to ping something which is in USA, it will not go directly. That doesn't exist. So what this request does, it goes to different networks, a network of networks. That's why we call it internet, interconnected networks, and until it gets to its destination. So it uses the shortest path. Instead of doing something like this, it goes something like that. But in Google Premium tier, it goes here, for example, in Italy, and then it enters to the Google network. Now, what do we have in Google network? If I come back here, network, here is how it's built, the Google network. So if I come here, as you can see, I'm here. So Google is split on regions, and each region, it has its zone. So when we use platform as a service, we don't really bother ourselves about those concepts. But when we use infrastructure as a service, we need to understand those concepts because it's an infrastructure. We need to understand what's going on in the deep. So a region, that's a region. That's a region. And each region, it has at least 3 zones. Let's say data centers, A, B, and C, for example. And as you can see, let me show you something else. They always try to make a region in each continent. So if I come here and I show you this car, so let me open it in new. So if I come to our region, because we are in MENA, Middle East and North Africa, so there will be 2 regions soon. There will be one in Doha, in Qatar, and then there will be another one in Dammam, in Saudi, which means that we will have Google data centers in MENA soon here. So if I want to use the premium tier, it goes, for example, here, and then all those blue and white, they are called regions. And in each region, there is what we call a zone. So why we do that? Because someone who is living in Saudi, it's better to host his website in or his solution, because saying just a website, that's not really, because now we need complete solutions because we are all migrating to the cloud. So he will put it here in, for example, in a Dammam. Why he has to go to Warsaw or to London? He just come here, and then his latency, because in 2022 and future, there will be, this is not the war about bandwidth. This is the bandwidth. I have someone here, someone here. The problem is no more a bandwidth. The problem now is it fast to go and come back? So this is what we call a latency. But this one, we call it a bandwidth. And the bandwidth, this is not a problem anymore, because with ADSL and 4G and 5G, we don't have this problem anymore. But we have a problem about latency. And in Google, our latency, it will be really small. Why? Because all those regions, they are connected using fiber optics. Fiber optics, which is really fast. And by the way, Google is investing submarine cables. So if I come to this and let me search this, submarine cables, Google. So if I come to this, as you can see, those cables, are by Google. So Google himself is investing to improve internet. So he is from the few investors who is investing in submarine cables. So not only the infrastructure about data centers, but the network too. So let me come back here. So when we create our compute engine, we are choosing the region and the zone. So the region, this is the biggest part, and the zone, this is the sub part. So if I come here, so we have the region, and then each region, so if I come here, as you can see, let me use the pen again. So as you can see, we have a global, which means that, by the way, Google Network, it's global. It's not regional, it's global. So remember, that means that if your machine here, if you have a resource here, for example, a disk, because there are resources that are regional, there are resources that are zonal, and there are resources that are global. So for example, a disk, if we use store something, you can have it here and still retrieve it here. That means that it's global. Regional, that means that if you have this region and you store it here, you can still retrieve it here. And zonal, that means that only by zone. So Google Network, it's global. That means that this all connected. If you ping some machine, you get it. And then each region, it's split on regions, and every region, it has a zone. So when we use compute engine, we need to host it in a zone. But when we use a network, by the way, this is called software defined network. So Google's solution, it's called software defined network. What is a software defined network? In few words, this is you take a hardware, you take switches and routers, for example, Cisco routers and switches, and then you combine them, and then you program a way to make your request so fast, for example, the shortest path and all those algorithms, and then you even expand the bandwidth. For example, if you have 1 gigabit per second, you are limited in a hardware by 1 gigabit per second. But what if we combine a lot of switches and then make it think that's, for example, 1 terabyte per second? We cannot have a hardware that can assure it, but we can have a software and trick the hardware and make it think that it's really 1 terabit per second. This is just to make you understand what is a software defined network. And then we have a software defined storage, which Google does with Google Cloud Storage. That's another suite. Let me come back here. Okay, so Google then realized, made the compute engine. So compute engine, this is where you need to do a lot of stuff in a deep way. That means not only the compute engine, not only the machines, but the network. So when you come to the network, as you can see, we call it a VPC. VPC, not VPN. VPN for virtual private network. VPC for virtual private cloud, which means that you can manage your IP address, you can manage your router, your routes, your firewall, your subnets, all that stuff. So you can create your load balancers. So this is like the old way. You create machines, and then you put a load balancer, and then you invest everything in a deeper way. So let's have a recapitulation. So let me delete this, because there is one thing. You need to understand one thing. When you use Google Cloud, you need to understand that when you finish doing something, don't keep it. You need to delete it, because as long as it's there, you are paying for it. Now we will see the serverless that has another story. So let me come back here, and I need to delete this address. Okay. And okay, it's not attached. That means that I can still attach it to a virtual machine. And since I didn't do any machine, I can reserve static address. So let me delete it later. We don't have time. Let me come back here. So what we saw infrastructure as a service using compute engine. That means that you host your own machine, you go using SSH if you are using Linux, or you use RDP if you are using Windows. And then we saw platform as a service, then using App Engine. So App Engine, we saw that there are two ways. We have the standard, I code, I host, and I have the flexible using explicitly containers. That means that I can do whatever I want using flexible. And the standard, we saw there are two generations, first generation and second generation. So if in case you have Python 2, you are still stuck with first generation, or you can still use flexible. That's the trick. You can go to flexible since it doesn't care about the version of Python. It's still just a container. And then this is the old way. So now we talked about flexible. So people then asked for something to manage their containers. And the answer from Google was Kubernetes. You need to understand that Google, since he was and he is still running containers, he has his own technology that's called Borg. The technology that manages the containers is called Borg. Why we need to manage containers? Because since they are isolated, this container doesn't know about this container. So A doesn't know the existence of B. We need something that synchronize and take care if A goes down, I need to recreate another A somewhere. So I need to reschedule, I need to scale, I need to scale up, scale down, and so on. So we need this technology. So Google, they use a technology called Borg. And Borg, they give for the public, for us, what we call Kubernetes. So Google is, the Google team is behind Kubernetes. Even if you find that Kubernetes is used by other big brands, in reality, Google made Kubernetes. They gave it as an open source for the CNCF, for Cloud Native Foundation, and then the big companies came to that project and they start working on it. So remember, Kubernetes is born from Borg. Borg is the technology that makes Google manage the containers. So since Google invented Kubernetes, why he doesn't give us a solution how to manage this? And they created Kubernetes. Sorry. Before I show you this, let me come back to this graph. We have infrastructure as a service. We have platform as a service. And then we have software as a service. So they created here container as a service. So container as a service, this is a way how to host Kubernetes and fully manage it by Google. What we do, we just upload our containers here and decide the scale up, scale down, all that stuff, and everything else is managed by Google. And this is Google Kubernetes Engine, GKE. So GKE, this is the Google's solution how to manage our Kubernetes online, because you need to understand that Kubernetes is difficult to manage on premise. This is just a nightmare. So the best way to do is to come here, come to Kubernetes Engine, and then we create our cluster. That means that we can create a cluster, we upload our containers, and then we manage it in a more advanced way. Because remember, We said earlier that I can still upload my container in App Engine Flex, which is flexible. It's still a container, but since it's a serverless solution, my objective, don't forget, I'm working with developers, and developers don't care about the infrastructure. But if I need the container, but I need to offer a way to give them much more power, then I need Google Kubernetes Engine. This is like combining App Engine Flex with Google Compute Engine. So it's between App Engine Flex and Google Compute Engine, because each time we create a Kubernetes cluster, in reality, it creates a Compute Engine instance, and that's the trick. But I give the user those Compute Engine instance, and I tell him, now you can manage them. So this is the other solution on, as you can see, we need each time to enable the API, because when we are in the cloud, we are working with the API. That means that when I do something like this, Gcloud, this is a command. But each time I do, for example, Gcloud app, let me show you first what is Gcloud. This is the SDK. So if I do something, oops, it crashed. If I type Gcloud, it tells me, what do you want? Do you want, as you can see, if I come to compute, we have the app for App Engine, we have compute for Compute Engine, container for GKE, Cloud Function, and run. Those one I will talk about them in a few minutes. So as you can see, I tell them, for example, Gcloud app and deploy, and it will host my application. Please check the playlist because we already did that. So today I'm just telling what do we need for what, because we have a lot of technologies, but we need to understand why do we need them. So to wrap it, so App Engine, this is, you are a developer, you don't care about the infrastructure, you code, you upload, and that's it. And we have two, flexible and standard. Flexible, this is using containers, so you are open to do whatever you want. As long as your container runs, it will run on flexible, but you don't have the infrastructure power. This is why you need to use Kubernetes Engine. Now you want to use virtual machine. You get to the cloud and use the virtual machine and use whatever you want. Host an application, do your calculation. Here you need Compute Engine, but in one condition. You need to associate it with VPC network, because it's a network. So you need to configure your firewall, you need to understand what is your IP address, your subnet, and all that. And then we have those two products, which if we come down, we find that Google regrouped them under what is called serverless. So sorry. Okay, where is it? 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 Okay, there is it. So serverless, we have Cloud Run, we have Cloud Function, and then we have App Engine. So as I said earlier, App Engine is considered serverless too. So Cloud Run and Cloud Function, now the need came after the microservice philosophy. So what does a microservice mean? Is that in the past, we were using a monolithic application. That means that I take my application and I upload it in one single file. And this is bad. Why? Because, for example, if someone wants to list the address and everyone is adding address, this is my application. The problem is that because all the traffic goes here, my CPU is focusing on this. So that means that people who want to list an address, they find the service unavailable. Why? Because all the resource I sent them here. So what is the trick? The trick is, instead of using one single file, I'm going to split my file into small chunks. first file, second file, third file, fourth file, and then as long as I want to, this is the final result. This is my application. So the good news is that I'm going to make it as containers, because as I need a lot of resources, that's fine. I will spawn containers, because the difference between container and virtual machine is that a container takes less time to spawn, but a virtual machine needs few seconds or maybe 1 minute to spawn. So I have a lot of people come here, that's fine. I give them containers. I have one single person here, that's fine. I give him one container, and since they are isolated, I can scale up and scale down without any problem. So this is using containers, and this is what we call microservice architecture. Please check my video about Cloud Run and Cloud Function. So the technology that we need to use this, we use Cloud Function. Cloud Function, I write each container, I give it only one function. So if I come to my code, let me show you a code, an example. So if I do ls, and let me do cat main.py, as you can see, I have two functions. One function, second function. In Cloud Function, I cannot include them in a single container. I need to specify each function alone. So let me run this code, and then I explain you this. So I told him, Gcloud function deploy. I have my function. I need you to deploy it and name it hey there. I want people to access without authenticating. And then I need the entry point. This is hello A. I need only this working. Now I need to run it on Python 3.7, and then I have what we call a trigger. So Cloud Function, we use it each time we need a trigger. And this is what we call an event-driven architecture. So let me go to pricing and show you something important. So if I come here, as you can see, if I was hosting my application using the old way, for example, I decided to put it on Compute Engine, I got an IP address, and then I host my application. The problem is that as long as my machine is running, I am paying money, because that's how the old model works. But the serverless, I am only paying for the requests and not when my CPU or RAM is empty. Not, for example, my CPU, it was like this. Someone came and requested only this. Why do I pay for this too? So in serverless, I only pay for what I am consuming. So the serverless, this is the best way, and this is the most affordable way to host the application. Why? Because I'm not paying for 24 hours. If my application ran for 5 minutes, I will only pay it for 5 minutes. I will not pay it for 24 hours. And that's another layer. So let me explain you what I mean. So in the beginning, I told you, in the beginning, I told you that the good thing about cloud is that instead of buying a machine and make it run 24 hours, 7 days, 365 days by a year, I am losing a lot of resources. So I told you to go to the cloud. So the good news about cloud is that I only pay it for what people come to use. So the problem about this is that imagine that I used it, for example, for 3 days. But for example, from 1 a.m. to 5 a.m., no one come to my website. Why do I pay for this? And the best solution is to use serverless. So the serverless, this is a way to make me gain those 5 hours of money. I will take them to my pocket. So this is the difference. And Cloud Function, we use it to trigger something. So how do we trigger something? Either we click, this is an HTTP trigger. That's why I put here. Let me show you the command. So the command here, I told him I want to trigger it using HTTP. That means that if I come to this website and I run it here, it works each time someone comes to this website. That means that if no one comes to this website, there is no trigger. Or the best way we use Cloud Function, this is when we want to connect it to another service from Google Cloud. PubSub, publisher subscriber, Cloud Storage. Why we need Cloud Storage? Imagine this scenario. I am using machine learning. You know that Google is the first in machine learning. So I want to upload a cat picture. Sorry for this bad drawing. This is a cat. And I want to upload the picture to Google. I want to make an application where each time someone uploads a picture, I tell him this is a cat or this is a dog. So instead of developing my own machine learning algorithm, I take Google's machine learning API and then we call it Vision API, for example. But I want to make it trigger. So how am I going to trigger this function? I just bring Google Cloud Storage and then tell him each time you see a change in my bucket, we call it a bucket, this is like a disk. Each time you find something that changed in my Google Cloud Storage, trigger this function that calls Vision API. And this is the best way to use Google Function. So this is using serverless way. That means that as long as no one uploaded a picture to Google Cloud Storage, my function will not work. Can you please add me 10 minutes so we can finish? Now, the latest one is Cloud Run. So what happened with Cloud Run is that people came to the beginning of the story. They said, hey, we want something like App Engine, but using the benefits of GKE, of the serverless. So those two, if we combine App Engine, where people were flexible, where people were able to upload their code as a container, where they can manage it, but without breaking their head. And this is Cloud Run. So Cloud Run, this is a way to use the old App Engine behavior using the Kubernetes technology and using the serverless. That means that if no one comes to my application, I will pay $0. And there is something. So if I come back to my example, come here and then do cat main.py. Now I can put those two in one container. So if I need to put them both in one single container, since I cannot do that in Cloud Function, I will do it in Cloud Run. I can do it in App Engine Flex, but in Cloud App Engine Flex, it's been here since, let me come here. So the App Engine Flex, this is the standard and this is Flex. As you can see, 2016, but this is 6 years since this date. So we need something new. And this something new, this is using Cloud Run. So Cloud Run, this is the way how we are going to use our the benefits of App Engine Flex and the serverless world. The serverless world, that means that if no one comes to my application, I will not pay anything. And those are the technologies that keeps evolving. So they are still here. Even the old technologies are still here. So it's up to you to choose. So let me do a recap. We have a code and we need to upload it somewhere. So let me zoom this to create a black desk. And let me, okay, this one is perfect. So they started with PAS to say platform as a service, and this is App Engine. So App Engine, this is built for people who want to code but without caring about their infrastructure. So if I come to, let me show you something. CD App Engine. If I do ls, I have my main.py. This is a simple Flask code. As you can see, this is just a simple Flask code. But I don't bother myself uploading it as a container. I just do Gcloud app deploy and it will go to my project. As you can see, it will start uploading it. I don't care if it's 2 GB of RAM. I just need it to scale. So yes, I want to continue, and you will see now that it works. So now the details how it works, please check the videos. Now people then said, hey, this is App Engine and Google invented Gvisor. They need to change things because in the past it was sandboxed, so it was the standard way. Standard first generation. Then they created flexible using containers. But people didn't like flexible because they say, hey, we want something like in the old way and much faster. So this is the second generation. Because the flexible, they run compute engine. So you need to deploy, you need to run compute engine, a virtual machine, which costs few seconds. But in standard way, they still use their old technology, but now they use Gvisor. Remember, because we need to sandbox our container. Then people said, hey, we want infrastructure as a service. So Google gave them Google Compute Engine. In Compute Engine, you have the full control of everything. You install, you get to SSH, RDP, you configure your IP address, anything you want. Then people said, what if we want something about containers, but something where we can use our compute engine? Then Google realized the container as a service. So container as a service or Kubernetes as a service, as you want. So here they realized Google Kubernetes Engine, where we can create container and then we create a cluster on Kubernetes. Google manages this fully managed service where you can host your own container and manage them as they were in Compute Engine. And then people said, hey, what if we want to use the event-driven architecture or paradigm, or use the old way and combine the best of all this? And then here they realized Cloud Run. And if you want something with event-driven, then you have Cloud Function. So if you want to trigger functions on, of course, both of them use containers. So if you want to host something and then want to fire it each event, that means that if your day no one came to your website and then only one visitor come to your website, you will pay only for the operation that made your machine on that user. And Cloud Run, this is the same thing, but instead of making it easy and simple, a simple function, here you deploy a complete application like we did in App Engine. So those are the products. And now the future, this is using the multi-cloud and the hybrid cloud. So the hybrid cloud, this is a way where I use my own premise. On premise, I have servers, and then I want to connect it to Google Cloud. Here we call it hybrid cloud. A multi-cloud, for example, I have someone who comes from Amazon and says, hey, I want to use something from Google Cloud too. Then you can connect what you use on Google Cloud on Amazon or on Azure, on Microsoft Azure. How we are going to connect this? We can use Cloud Run, and then we use a service mesh, or what we call Anthos. So Cloud Run, let me show you something. We can still use Cloud Run using GKE. So if I do Cloud Run, GKE, and where is Google Cloud? So there are many articles about this. Here is it. So we will use Anthos. So Anthos, this is a service mesh. That means that you can connect a lot of services, even if you are not hosting the same solution, the solution on the same servers. And this is the future. So you need to understand first how Kubernetes works. Once you understand Kubernetes, how it works, then you can go to Anthos. And in Anthos, you can understand what is a service mesh, and then you can deploy your Cloud Run in a hybrid way. So this is the future, because Google keeps evolving with the market need, and the market need is the hybrid cloud using a serverless architecture. This is it. Let me check about your questions. If you have questions, please ask them. I hope you understood the purpose of each product. And of course, we didn't talk about data engineering and all the other products. Google Cloud is really huge. So we just talked about how you are going to host your application. So let me, do you have any question? يمكنكم طرحها بالعربي، يمكنكم طرحها بالإنجليزي، يمكنكم طرحها بالفرنسي، أي لغة تريدونها. So, do you have questions before we end? We started these sessions since January 2021, and Alhamdulillah, we are still here. And of course, there will be another year, inshallah, 2022. In سنقوم we will do another other sessions, and this time we will more focusing on how to program a complete solution. And alhamdulillah أننا ما زلنا مع بعض. شكرا جزيلا لكم. هذه هي آخر حصة من حصصي في عام 2021. شكرا جزيلا لكم، وشكرا لكم على حسن المتابعة والإصغاء. أتمنى أنكم تعلمتم ولو شيء بسيط مما قمنا به. طبعا السيشنز كانت فيما يخص السيشن التي أقدمها كانت بالإنجليزي، لكن الإخوة ما قصروا، يعني عملوا سيشنز بالعربي. يعني please check the playlist. يمكنكم رؤية إعادة البلاي ليست. هناك أشياء كثيرة يمكنكم تعلمها وهي مجانية. يعني يمكنكم حتى إذا فهمتم أن تفتحوا مدرسة خاصة بكم. شكرا جزيلا عمر إبراهيم. شكرا أسرار. إذا لم تكن هناك أسئلة، شكرا جزيلا. و هناك من سأل RDP. RDP هو it's a way how to connect to Windows machine, because the difference between Windows and Linux, I access to Linux to type codes, to type commands, but people access to Windows to use the mouse like this. So because I need the mouse, here I need the desktop. So that's what we call remote desktop protocol. Desktop protocol. This is like a TeamViewer and all those stuff. Even Google, by the way, it has his own solution. You can have, let me show you this, even it's not cloud, but you need to instead. So if I do a remote desktop, Google Chrome. So you can use this, it's free, and it's the same thing. You can use your phone directly to your machine, and then you can use the mouse. You can use your phone as your own computer. You can access your files, you can do whatever you want, and it's free. So you can use this, it's free. This is for you. Okay, so and RDP, this is a way how I am going to access to this machine and use the mouse. So remote desktop protocol, and you can use a lot of tools, and in Google extension, Google Chrome extension, it has the RDP tool. So everything, Google Chrome is really strong. You need to investigate more about it. إذا لم تكن هناك أسئلة، إن شاء الله. إذا لم تكن هناك أسئلة، شكرا جزيلا لكم، وأتمنى أنكم تعلمتم أشياء بسيطة. يعني حاولنا أن نبسط الكلاود أبسط شيء ممكن. طبعا هناك العديد من الفيديوهات، هناك العديد من الكونسبتس، وكل يوم هناك شيء جديد، ولا ننسى وقل ربي زدني علما. يعني العلم لا يتوقف، دائما كالبحر. لهذا أنصحكم دائما بالتعلم وعدم التوقف وعدم القول لا أعرف هذا الشيء. هناك لم نولد نعرف أي شيء. مهمتنا في الحياة هو التعلم والدراسة والتعلم والتعلم والتعلم. شكرا جزيلا لكم. نتلقى في ساعة الخير إن شاء الله. أتاكم بالجزائر مباشرة. So see you in another season. Thank you very much. Thanmir Thanwin, and see you soon.